Today we're beginning lesson 8.3 on functions and equations. We've already gone over function tables in earlier lessons as well as earlier chapters and equations in the last chapter. So our first concept that we're going to go over, and we've reviewed this before, is what does linear mean? So Michelle, what do you think linear means? She says maybe it's something with a line. Let's see. Andrew, do you have any idea what linear might be? No? You don't want to take a guess? So our warm-up, page 595. Just do part 1 and 2, question 1 and 2. So write a sentence that describes the relationship between the number of hours she babysits and her earnings. It should be pretty simple. Yes, Rocco.
1 hour equals $6.
Excellent, that's great. She earns $6 per hour. And we know that per means 1. We could also say that in 1 hour, she earns $6 babysitting. She earns $6 every hour she babysits. Every hour she babysits, she earns $6. The point that we're trying to convey is every 1 hour, she earns $6. So does she earn the same amount every hour? We all know the answer is? Yes. So she earns the same amount each hour that she babysits. And we see this because the ratio table, our function table, is matching on each side. So when we see that it's matching on each side, we remember this from before when we were doing some form of graphing. Which one here is X, the hours babysitting or the earnings? The hours babysitting or earnings. Which one is our X coordinate? What do you think, Daniel? Yes, the hours babysitting. So that one's called our independent variable. Why do you think that's our independent variable? I'll give you a hint. The other one is our dependent variable. Mario?
Because it's by itself.
It's by itself. I mean, it goes with earnings. So what Hannah?
Because the earnings, to get the earnings, it depends on having the hours babysitting.
Yes. So the earnings depend on the hours babysitting. If she only babysits 1 hour, she only earns $6. She only earns what she works. So it is dependent on our x-axis. So if you're ever presented with a problem and you don't know which is your x variable and which is your y variable, your x is your independent. It is not reliant on the y. It is our input. It is what we put in, not what we get out. So we see this up at the top, and we've already filled out part of it, and I want to look at the rest. So we see that linear means having the form or resembling a line. Pretty easy. So what do we notice about this graph? I'm not even going to ask you because the answer is it is a line. That's what we notice about this graph. We notice that it doesn't swoop up like this. We notice that it doesn't curve down. We notice that it is just simply a straight line. And how do I know it's exactly a straight line? How do I know that it's exactly a straight line, Hannah?
Because every time that, if you look at the numbers, it goes up 1, 1, 2, 2.
Exactly. It goes up 1, 1, 2, 2, 3, 3, as we know it matches. What if it went up 1.1 and 1.1, and then 3 and then 3? Is that going to be a line? What do we think? Raise your hand. What do you think, Lucy?
Well, since none of the numbers are matching,
If it went up 1.1 and 1.1, and then if it went up 3, 3.
Yeah, then it would just go like this.
So it actually would be a line because they're going up the same amount when our y and our x are going up the same amount each time. So if our x started with 1.1, I'm so sorry. You're right, actually. It's not a line because 1.1 would be going up and down. I meant 1.5. If it went up 1.5, comma 1.5, and even if it went up that 1.1, we wouldn't know unless we had a third plot point. So 2 plot points are not necessarily enough to know if it forms a line or not. And here's the reason. If I had my nice line, although Lucy was right with my example I was trying to. So if we have 2 plot points, we say that we're at 1 and 1, and then we are at 2 and 6. Do we know if that's a line or not? Not yet. We only have 2 plot points, so of course we can make them connect. If we only have 2 plot points, no matter what, we can make them connect. But let's say I found out here, I have 3 3. Is that going to be a line? No, because it would go like that. Quite frankly, not a line. We need 3 plot points to figure it out. The everyday definition of function. Everybody got a definition? What's an example? Let me see. Fernando, what do you think is a definition of the word function? What is function in real life? Exactly. The purpose. That is exactly what it is. The purpose for which something is designed or exists. It's the exact same, actually, in mathematics. We see this. Our relationship then assigns exactly 1 output to 1 input. So the function of something, the function of a pencil is to write. And we're able to utilize it for other things. But in math, we typically only utilize it for one thing. However, we still are. We could make a T-chart. We could graph. Many different things. But the definition is a function that assigns exactly 1 output value to 1 input value. I like to think about it as a machine. So we have our little box right here. And we have 1 input that we put in. And it pops out exactly 1 output. It pops out exactly 1 output. And even though the input will be different each time we put it in and the output will be different each time it comes out, it still follows in that same system. So it still follows in that same purpose, that same relationship. They're going to have a correlation. It's not going to be utterly random when we plug it into the same function. And if we remember, output. What is our output value? Is it our X or our Y? Let's see. I want to see a hand. Hannah. It is our Y, exactly. It is our output. As I said before, I remember it because input I comes before output O and X comes before Y, if you ever need help remembering that. And because X is our independent, we put it in independent input. That's helpful too. So, what about this formula? I'm going to ask you this. If this relationship works, do we have something that works? So let's pretend this was babysitting and we had the same thing. Let's pretend that this was babysitting as well. So let's look at this one. This reminds us of our homework. So is this gonna form a straight line or no? Rocco?
Yeah, because it goes up by 6 every time.
Exactly. Even though we don't start at that 6 number, here, we're going up by 6 every time. In fact, if we were to write a function for it, we already know that since it's plus 6, it's going to be equal to 6x because it's on our y side. It's plus 6, it's going to be equal to 6x. But is 6x enough? If I plug in 1, is that enough? Will that get me my answer? No, it will not, right, Michelle? What do I also need to add to this, Daniel? So it's not going to be 6 plus x because even though we're adding, oops, it's not plus 6 on this side. It's plus 1 always. Just on this part. No, because it's 6 plus 6 on the y side, we know it's going to be multiplied times 6. Michelle?
It would be 6x plus 5.
Yeah, it would be 6x plus 5. Now, the reason that it's multiplying by our 6 is because here it's correlating. We're going up 1 each time. We're going up 6 each time. We see that, so our output is going to be 6 times what our input is. Our output is 6 times what our input is. But it's also got that special condition to it. It's automatically got a plus 5. Since our first one starts 6 times 1, but it has that plus 5. We'd see the same thing if we went up 7 each time too. It would just be a 7x instead. 18, 25. I'm just going to end it there so that we don't have that problem. Here, since it's going up 7, it'd be that same 7x, except in this case, it would just so happen to be a plus 4 based on what it starts at. That 4, that's our constant. Do we ever get more than that extra $4? Do we ever get more? Let's see. Gloria, do we ever get more than that extra $4 in the beginning? No, it stays. We got that extra $4. Someone was desperate to have a babysitter that day, so they said, you know what? I'm going to give you $4 just to come in, and then I'm going to give you $7 extra hour. Good incentive, right? So that's why we end up with our formulas looking more like this, our functions looking more like this. Now, if I had this graph, I want you guys to fill out this T-chart. Here is our function, and here is our list of inputs. So we're going to fill out that T-chart. Perfect. So what is our first Y value? What is our first output, Carmen?
-1.
So it's not going to be a -1 because we're going to plug that input into our function. So what do we get then, Liam? 1. Exactly. We get 1. What about for our next one, Anita? If we plug in the 0 into our function, we plug it into our machine, we get 2. What about our next one, Romario?
4.
No, not 4. What is it, Rocco?
Wait.
We plug the 1 into here.
3.
We get 3, and then Romario, for the last one here, we get 4. I'm going to point something out. Here, how much are we going up each time? Lucy, yeah, actually, I want to see it on your fingers. How much are we going up each time? We're going up 1. Notice that it's just 1x, or simply, remember, 1x, if you can't remember that, same exact thing. 1x is just x, because you only have one of them. So, it goes up 1 each time. That's why we multiply. But we look at our initial one, and we see it has a difference of 2. And that difference of 2 does not change anytime. That difference of 2 does not change. So I've mentioned this before. I believe that we've seen this in this class. We've seen y equals mx plus b. And it's going to be very related to this lesson. Looks complicated. We've gone over it before. It's not as scary as it looks. Our m means our slope. And our b, we're going to go over that in a minute. But slope. When we think of slope, what is the real life example that you might think of? I want to see Jaden. Yeah, it's a good with your arms. Yeah, we see that. I might think of like a ski slope, in which case, you're going down a hill. A skateboard slope if you're skating, where you're going down and or up some sort of hill. A slope is how tilted something is. And yes, it, by the way, is possible to have a slope of 0, which means that it is absolutely flat. We're not going to get into that later. That will be one of our more fun facts at the end of the chapter. So we have our slope. That is how much we go up or down. Then we have our b. Our b is our y-intercept. It's called our y-intercept. What does intercept mean? If you're going to intercept something, Rocco? I know it's hard to put into words. What do you think, Liam? Switch directions, not necessarily, but that's good. It's in football. When you intercept, then you switch directions. But what is it? Sort of, to stop. That's where, Jenna, what do you have?
It's where lines cross.
It's where lines cross. That is our math definition. So our intercept, when you intercept something, it's when they meet. So in football, if you intercept the ball, that's when one team met the other team or one player met the other player and took the ball. An intersection is where cars, we've got 2 lanes of things, they meet up. Intersection. So our y-intercept means where it intercepts, where it meets the y-axis, our up and down axis. I've got a question. This is tricky. What do you think the y-intercept here? What do you think our b in this equation is? This is an advanced question. So what do you think, Rocco?
The point where
What number do you think it is? I know, it's a tricky question.
I don't know the number.
What do you think, Gore? Y? Yes, but what's the number? What's our number, Daniel? He thinks it's 1. We want to know, we're looking for the number where it's going to touch this axis, where it's going to touch that line. I know, it's a very advanced concept, Daniel. Not 0, but we're really close. We're getting closer. What x value is this? Right there. Romario, do you know the x value? What's the x value, Gloria? Not -1, the one right here. What is that x value? The one right here in our center. Miles.
The origin?
It is our origin, and what is the x value of our origin? What is the value of our origin in general? Yes, our x value is 0 at that y-axis. So what is our y-intercept, Lucy? 2. When x is 0, y is 2.
How? What?
It follows our function right there. Yeah.
X is 0, Y.
Oh, when x is 0, y is 2. If I said it backwards, my bad. When x is 0, y is 2. So that is our y-intercept. That is our y-intercept. And if we notice, when x is 1, here is 1, we get 3. When it's -1, we get 1. Notice how this is going to form, by all means, a nice, that did not help, a nice straight line. Yes, Rocco. Yes. So it intercepts our y-axis at that point right there, too. For our advanced topic of the day, what would the value be right here? What would our y value be? Anita? 4. Perfect. And that is also our y-intercept, because that is when x is 0. That's our y-intercept, because that's when x is 0. That means that's going to be our constant, our value right here at the end. And then how much are we going up each time we go up one value? Or we can see it, we can divide it. And I'll actually teach you a trick that we're going to do. So, how much do I go up here? How much am I increasing by? Yep, we're increasing by 2. How much am I increasing by here?
2.
We're increasing by 2. Our slope is going to be our x value over our y value. It's 2 over 2. It might be our y value over our x value. It's not important right now. So our slope is 1. We get our formula to be x plus 4. Don't need to understand this. This is our advanced concept of the day.
Isn't it plus 4 plus 2?
So here, our m is a slope. It's the coefficient of our variable. And our b is our y-intercept, the constant. Just like when we were babysitting and they gave us that $4 initially. They said, just for coming in. That would be our constant. It does not change. And the slope is how much she gets paid. It's the same amount. So in your notebook, I want you to identify the slope, and it says of, I want slope and intercept. Actually, I want both. Slope and intercept. The slope is simply going to be the number in front of x. And what if I just had a y equals x plus 3? What would our slope be here? What is it, Liam?
3?
No, because that's not the number in front of x. Good guess. That would be our y-intercept, our constant. What's the number in front of x here?
1.
If we don't have one, what is the number in front of x?
Unknown.
What is the number? How many x's do we have?
1.
We have 1 x, says Miles. Correct. There's only 1 x. Even though we can't see the number, remember, if we can't see the number in front of a variable, our number is 1. So, identify the slope and the intercept. Let's see. For the first one, Miles, what do we have?
Slope?
Perfect, we have a slope. Do we have an intercept? No, there's no plus anything, minus anything. So what is our slope then, Miles?
3?
Yeah. Slope is 3. It's that simple. What about the next one? What do we have, Jaden? Do we have a slope? Do we have an intercept? Do we have both? So in this one, just to help you out what do you think, Adriana?
Intercept?
We do have an intercept. So one of them, we have our intercept, our b, and what is it?
1.
Yeah, positive 1. Just make sure that you know that. But we also have a slope. Exactly. Rocco's completely right. Our slope is 1 because we have an x value. There is no 1 that's written there. There is no 1 that's written there. So what about this next one? This is a little tricky. I'll give you a hint. It can also be written like that. Do we have a slope? Do we have an intercept? Do we have both? What do we have? What do you think, Jasmine? What do we think then, Lucy? Yeah, the slope is 1/4 because that's the number that comes in front of x. What about this last one? What about this last one? Malia is just here, so never mind. What did we get? What do we think? What do you think, Rocco?
I know there's a slope.
You know there's a slope. It's true. Whenever we have an x, there's a slope. And we have an intercept. What's our intercept? Hannah.
3.
It is -3. Exactly, Hannah. You can't forget the operation that's happening right in front of it. That applies to the concept. And then, let's look up. What is our slope then? What is our slope, Lucy? 1, because there's nothing in front of that x. It's just that one x. Yes, Rocco asked a great question. He said, since we don't know x, we make it into 0, and that's our y-intercept. Correct. Whenever you get a function, you make the x equal to 0, that's your y-intercept. In fact, that was my next question. What is the y-intercept here?
0.
It's 0. Notice if we made x 0, we would get 0. And notice there's a plus 0 at the end. Do we ever have to show there's a plus 0? No, because we're just adding 0. So, we're going to look at this. How to graph linear equations. This is not a page that we're looking at, but to review, you can see it's chapter 5, lesson 7. So we make a t-chart. We put numbers in the input, and we solve our output. Then we graph. It's input, comma, output, x, comma, y. Anita, if it will help you. So we already saw this. Example is x plus 2. I like to, whenever I do graphing, give it one negative value, a 0, and one positive value. And those are pretty much the easiest. So we did this one earlier. At negative, we got 1, 2, 3. Notice that it's following a line.
Yeah.
So we got at -1, we got 1. At 0, we got 2. And at 1, we got 3. Follows our nice little line. But what happens if I changed it up? What if I got 3x plus 2? What if I did 3x plus 2? What would my first value be, Hannah? So, let's think about it. Once again, all we have to do is plug in. So we plug in -1 here first, and we follow PEMDAS. -1 times 3 is -3. Plus 2, we get -1. The next value, we plug in 0. What's 3 times 0? What do we get? Yep, 0 plus 2. Still 2. Notice that plus is still our y-intercept. When x is 0, it's still our y-intercept. 1. Here we plug 1 in, we get 5. Let's look again, just when we're reviewing that concept. I'm going up a constant amount here. I'm going up +1 every time. +1 every time. And I'm going up +3 here. That +3, the one that it's going up on our dependent side becomes our slope. That becomes right there our coefficient. And when it's 0, that becomes our plus. That's going to be the cheat way whenever you're doing this to make sure that an equation works and to write it the correct way. At -1, it's -1. At 0, it's 2. At 1, it's 5 right up there. And there we have our nice line. Still a line. You can change any part of a function and it's going to be a line, but it's going to be a different line. It's going to be a different line. So we're going to go to page 596, 597. We're going to do A, B, and C. So this first one, how much are we going up each time? How much are we going up? Rocco. Perfect. We are going up 16. So we already know it's going to be 16x because we're going up that constant +1. Okay? Do you see how we're going up that constant +1? It's different if we're not going up that +1. That's why it's going to be y over x, actually. In fact, to double check, and I'm going to pause this. What would our y-intercept be? What would our y-intercept be, Rocco? Actually, you totally do know it. So when x is 0, we just went down. What would our y-intercept be, Daniel? If each time we're going up +16, here we have to go, we're going up 1 each time. To get to 0, we're just going down 1, so we go down 16. What do we get as our y-intercept? Rocco? Not 15, what do we get? We have to go down 16 on that y value. Down 16, Romario? 0. Down 1 on the input, down 16 on our output. Because when x is 0, we went down that 1. So our formula is just this, which makes sense. Do we have any initial change here? 1 times 16 is 16. 2 times 16 is 32. 3 times 16 is 48. So our formula is just going to be as simple as 16x. Now, for b, if we graphed this, Daniel did a great example. He did -1, 0, 1. It doesn't matter. At -1, we get 0. So when x is -1 here, we get y as 0. At 0, we get y as 1, aka our intercept. When x is 1, we get 2, because we just plug it in right here to our formula. 1 plus 1 is 2. 0 plus 1 is 1. -1 plus 1 is 0. Notice how this would make a nice little line right there? Following our t-chart. All we're doing is we're just plugging in x values that we decide into the function and seeing what pops out. What if I put in the number for my x value 100? What would my y value be, Gore? If I had the x value, the input, 100, what would my y value be? It'd be 101. What if I put in 1,000,000? What would it be, Lucy? 1,000,001. Exactly. For this function, it's always just going to be that plus 1. It's always just going to be that plus 1. Think about plugging in our dependent variable and getting our independent. For this one, our second one, once again, I'm just going to plug in positive values. We're going to plug in plus 0, 1, and 2 just because it doesn't show us the negative part of the graph, so it's a little inconvenient. For 0, what is our y value? For 0, our y value is going to be, Oswaldo, do you have an answer? I just have to plug it in. I plug in 0 for x. What's 3 times 0? What's 3 times 0? Let's see, Gore. 0 plus 2? 2. 1. What's 3 times 1, Romario? 3 plus 2? We get 5. 2. I plug it in. What's 3 times 2, Liam? 3 times 2. 6 plus 2, we get 8. Notice this side's going up a constant 1. This side's going up a constant 3. That matches our slope. That going up that constant 3. When x is 0, y is 2, that matches that 2 right there. At 0, we get 2. At 1, we get 5. At 2, we're all the way up here. I'm not going to put it. We get 8. We get our nice little line like that. It's as simple as plug and play. You've heard me say that before. I love saying plug and play. So first, as a group, we're going to come up with an equation and then fill in this t-chart. 40 more than 2 times the cost. This was like our last chapter where we came up with expressions and equations. 40 more than 2 times the cost. First of all, let's think. We see this. More. What does more mean? Rocco. Addition. We see this than. It's not important when it's addition, but we know what does than mean? Rafi. Rocco. Not multiplication. We see the than. Romario. Not subtraction. We see the than, Daniel.
It's gonna be
After. So it's plus because it's going to be after. It's going to be here. 40 more. So it's plus 40. 2 times. That's multiplication. And do we know what the cost is? It's our unknown. That's it. That's our equation. That's it. Just like last time. Then we just plug in our value. If I plug in 0 for my value, if I plug in 0 for my x, what am I going to get, Nathan? Michelle. 40. Romario, what if I plug in 2? What do I get? Not 42. What do I get, Adriana? 44. What if I plug in 5? What am I going to get, Anita? 50. See how I'm just doing plug and play? I'm just plugging it in and seeing what value I pop out. So, page 598, we're going to do D, 1, 2, and 3. All we're doing is some plug and play. A tip for D. Fill out the T-chart first with the ordered pairs, then check for your slope, and then check for your intercept. Melanie, when X here is 1, what is our Y value? Perfect. When magazines is 1, we know that that's our X. It shows you it's labeled for us. Our Y is 20. Oswaldo, what about when it's 2?
25.
Perfect. 25. What about at 3? Let's see. Lucy. 30. And Raphael at 4. What is it?
4 is 40.
It's what?
40.
Not 40. What is it, Anita? 35. So, we see we're going up 5 each time on our Y value. So we're going to have 5x. But does that 5x work when I just plug it in here?
No.
So what am I going to get? What is my y-intercept? What else do I need, Michelle? 5x plus 15. Excellent, because when we check it with that 1, we only get 5. To get to 20, we need to add that 15. And notice we check it, it works every single time. 2 times 5 is 10, plus 15, we get that 25. Additionally, here, I'm going up 1 each time. I'm going up 5. If I go down 1 to 0, I go down 5 to 15. And my intercept is when x is 0. So that's how we come up with that graph together. We're still going to do 1, 2, and 3. And your homework is page 599, 1 through 8. If we look at this one, our x is 0 and our y is 0. What is our y-intercept then? If our x is 0 and our y is 0?
0.
It is 0 miles. Yes, we do not shout out though. So we would have a plus 0 at the end, but it also doesn't matter. Here, we're going up 1 on each side and we're going up 4. It makes it y equals 4x. This next one, if we graph it, we just come up with our T-chart. 0, 1, 2. We just plug it in. At 0, we get 3. At 1, we get 4. At 2, we get 5. For this one, at 1, we get 10, 2, 20, 3, 30, 4, 40. So our equation would be 10x. Okay, that's the homework.